Hey guys, I hope you're well. Today we are going to have a look at Python Numpy library. So first off, let's start with what is a library. A library is an external code that someone has created and we can use majority of the times for free. Library provides many functions usually that we don't need to know how they're working, but we can use their functionality. For example, NumPy provides min and max operator, which can find the minimum number, for example, in an array, or the maximum number in an array. One more reason for us to use NumPy and in general libraries is actually NumPy is 3 to 10 times faster and more memory efficient than lists. This is the reason because in lists we can actually add a lot of elements which are of different types. For example, in a simple list, in a Python included list, we can add a string, integer, anything literally. And because of that, at runtime, we have to check over and over again what is the type of the element. Whereas with array lists, this is not necessary because we will know that array lists have only numerical value. Next on, we're going to have a look on how to install NumPy library. Of course, like we've discussed in the setup tutorial, for anything we need to install, for example, Python or packages, we'll have to use a terminal. If you're using Windows, you'll have to type in the search bar cmd, press enter, and voila, here's our terminal. So, to install a package, we will need to type in the terminal pip as first word install for that we want to use the installation, and package name. In our case, our package name is, let's see, NumPy. So we write pip install NumPy. That's it. So for me, this is already satisfied because I've already installed NumPy, but for you is going to be installing for about 40 seconds, which you'll have to wait. The second very important step that you have to do after you have installed your NumPy is actually importing NumPy to the Jupyter project. So you need to run NumPy, import NumPy as np. I'm going to explain in a bit. You have to also run it. Yes, now I'm going to explain what is as np and why we're using it. Import NumPy apparently is just importing the NumPy library. We are adding the statement as np. This is simply to make it easier, more readable and easier to type for code. As is renaming operator. So you can call it in any way. You can call it as a cat, and now you have to write every time cat dot something. But you want to write np. You basically want to know what is your package doing. So let's go on. Next important operator that you can use is that's included in NumPy libraries mpy dot, for example, any operator you're not certain of, followed by a question mark. So it could be np.min, max, anything really. This is going to return you information about the signature of the function, and anything you need to know about it would be here. What it returns, some examples, and the type of the operator. So the exciting bit of the tutorial, creating a NumPy array. How to do this? The syntax is very simple, however should not be confused to creating simple Python array. This is an array list and the syntax is a little bit more different. Here we want to assign our array list. This is the array list. We assign it to a variable a. We decided to call it a. You can call it in any other way you like. So we write equals for ownership, let's say, np.array bracket square bracket, and here you're declaring the elements you want to have in the array. You can have numbers. Therefore, we have just 4 numbers. This list is going to be of length And what you can do is you can do many operations on this array list. This makes it actually very, very easy to do a lot of things with array lists. So you can multiply each and every element in this list by 2, for example. And here you go. You multiply 1 by 2, you get 2. 2 by 2, get 4. You get the point 3 by 2, you get 6. And you can add 1. Here's going to be the result. And you can even square the entire array, each and every element. So for comparison, we have previously looked at the Python included lists. To do exactly the same operation, squaring each and every element in the list, you'll have to write this code here. So first you declare the list. Here's the declaration of the list. Keep in mind, here we are not using MP array lists. So first of all, you have to create an empty array. This empty array is going to be needed to store all of the values you have squared inside. This we're going to see in the for loop. Here we have for I in range of 4 because our list is of 4 length. We are going to add a list squared, the empty list, append, and we're going to append the squared ith element of a underscore list. And at the beginning, at the beginning of the iteration, where for 0, which is the first element in range of 4, you're going to have actually 1 squared, push it to the list, and then it's going to iterate to second element in the list, square it, and push it to the a list squared third element, and so on and so forth, and then you get the squared. What you cannot do in lists as well is squaring the list itself. You have to really do it with for loop. Therefore, it is really remarkably easy to work with NumPy array lists, and we should. Another cool feature of NumPy array lists is actually that you can do operations between arrays of the same length, NumPy arrays of the same length. For example, if we call an array B and assign it these values here and create another array which is of the same length as B, now we can do operations with them. We can add them, we can multiply them, and we can subtract them. So here first we're going to run the declaration part, and then we are going to run the operations. So here you have it. 3 plus 7 is 10, 4 plus 6 is 10, and 5 plus 5 is 10, and 6 plus 4 is 10. This is because we are summing the first element in the list with the first element in the second list, the second element of the first list with the second element of the second list, and so on and so forth. You're doing for all of the elements until the length is finished. So it is very important to note actually that we're having just simple lists. We cannot do any operations between lists because they're very, very simple, and we need to do manual code to compute subtractions between two lists, and MP array is just doing this for us already. So we cannot do a list minus b list because this is not array list. This is just simply a list in Python, unfortunately. These are our results. So I have edited the video so that you can see the outputs of what the outputs of the solution should be. But let's first look at the task at hand. We have 15 people that take math tests. They get a score out of 20, which has been put into a Numpy array, which means that we need to create a Numpy array of math scores, which should be 15 because the people that are taking the test are 15. For example, a score of 15 out of 20 should be a percentage of 75%. Using one or two lines only, print out these scores as percentage. So the results should look like this. I would like you to pause this video and think a little bit about how do you compute this and possibly try it yourself. Okay, and we're back. You have some results now? I hope so. But if you haven't, don't worry, we're going to have a look at how we're going to solve this problem. First, let's create an array list. We are going to call it S, and we're going to assign it np.array. Inside, we're going to create a sample data. I'm going to use mine. I'm copying over. So these are precisely 15 marks. So this is done. We have already created our array list of 15 people and scores that are up to 20. So next thing we have to do is actually find the percentage. How do we do this? How do you find the percentage of a score? You find it this way. You first need to have the score that you're receiving. You need to multiply it by 100 to make it into a percentage, and then divide it by 20. This is the total score you're receiving. So this is your score. Multiply by 100 to get a percentage and divide it by the score that is total. Result equals score is the S, multiply each element by 100 and divide by 20. Okay, let's see. This is going to work. Invoke the result. Here we go. We have received the same result. So yes, this is the task done. Congratulations if you managed to do it. If not, don't despair. We're just learning now. So indexing Numpy arrays. So how do we index our Numpy arrays? Here we have the first element is 5. The second is 4. The third is 2. But what is the index of this first element? It is 0, because please remember, index in programming always starts from 0. In programming, we start counting from 0. In fact, you have a 0 and 1s in the most low level of programming. So anyway, you are going to count from 0, 0, 1, 2. So what is the first element in the array? It's 5. And what is the index of the first element in the array list? It is 0. What is the second element's index? It's 1. So that's how it goes. You have 0, 1, 2, 3, 4, 5, 6, 7, 8 for array of 9 elements, because we start from 0. So here it is. If we want to take the first element in the array, this is the same as getting the item of index 0. We're going to do this. This is going to be 5. The fifth one is going to be 0, 1, 2, 3, 4, 5. It's going to be 2. Here it is. And when we want to get elements 3 to 7, for example, we're going to start from third element, so 0, 1, 2, 3, until 7th, but not inclusive. So this is going to get 3, 4, 5, and 6. So 5, 3, 2, 2. And if we want to get all of the elements until fifth one, but not inclusive, we're going to do take semicolons, take everything before the fifth element of index 5. So this is going to be everything here. So this is 5, 4, 2, 5, 3. Here it is. And if we want to get all of the elements from 5 until the end of the array, we're going to do from the fifth element inclusive until the end of the list. So this is these 4. Because this is the fifth element, we take it. So it may be a little bit confusing actually why the beginning fifth on, it's inclusive, but until the fifth is not. It's, I suppose, is just language. You take all of the elements until the fifth, but you don't include it. But you take all of the elements from the fifth index, including until first notice. So it's nice to think of it as English. If you say from, you say from this point on, you get all of the elements from this point until further notice. But if you say until this point, you take all of the elements from the beginning until this particular point, but not including it. We are now going to have a look at how do we compute Fibonacci sequence using Numpy arrays. This is not going to be that difficult compared to using simply arrays provided by Python. So to do this, we're going to use np.zeros. If you ever are uncertain what is a particular function included in the numpy package, you can just write np dot the name of the package question mark. And here we go. This numpy dot zeros return a new array of given shape and type filled with zeros. So the shape is just array list and the type is integers filled with zeros. So here we go, we have first print the initial array, we have printed it, and you can see it is filled with zeros. The first part of this program is to actually take the element at index 1 and assign 1 to it. Set element 1 to 1. So this means that this is element 0, this is element 1. So this is going to be set to 1 now. And then this is a for loop. And now I'm going to describe how it particularly works. From range 2 to 20, we are going to do for each element that starts from 2. So the second element would be equal to the previous element plus the second previous element. So this means that if this element here was 1, this means that this element here, which is of index 2, is going to be this element plus this element. So this element here is going to be 1 plus 0, which is 1. So this is going to become 1. And here it is, you can see it. It is indeed 1. So in the next iteration in the for loop, next we're going to have for I equal 3, where 3 minus 1 is 2, plus 3 minus 2 is 1. So this is going to ask us for this element plus this element. This here, the fourth element is going to be equal to, and so on and so forth. This element is going to be constructed this plus this. This is going to be constructed this plus this. This one should be 5 plus 3 is 8. 13 is 8 plus 5. And this is going to continue until the list reaches I equal 20. And this is the number that happens when I equals 20. If you are uncertain about anything here, you can always let us know and we're going to answer any of your questions. Functions. So NumPy provides a lot of useful functions such as min, max, mean, sum, and these are the ones that we're going to look at today. What it's important for us to know is that the function is called in the following structure: function, bracket, argument. So the argument is what we want to return from this function. So first off, we are going to compute the mean using the mean of the NumPy array functions. We're going to call it my array equals np.array. We're going to have an array of 7 elements, and the mean, what is the mean? The mean is the average between all of the elements. Basically takes all of the elements and divide them by the number of the elements in the array. For example, this is going to be 10, 21, 28 divided by 7. I hope this is the correct count. We're going to compute it. It is 4. So indeed, min and max, np.min of the array we've already created is going to give the minimum number of the array, which is 1. Here it is, and the maximum number of the array, which is 7. Here it is, and the sum of each and every element in the array, which is going to be 28. We've already discussed. Problem 2, for the following arrays that we're having here, we're going to calculate the range, the difference between the maximum and the minimum value. So how we're going to do this? We have the first array, the second array with different values, and the third one, and we're going to find the maximum of A1, which is the first array list, minus the minimum value. So this is basically going to show us what is the difference between the two arrays, how vast is the difference between the minimum and the maximum. So let's see. And the output is 44. And you can change 3 is 43, and you can change between the maximum of A1 minus the minimum of A3. You can do this as well, is 45. Okay, I hope that's clear. So let's go to linspace. Linspace is the function that would take an array of n evenly spaced numbers between a and b. We call it as follows. So numbers equals l and p dot linspace a, b, in and n, where n is the evenly spaced numbers. Where in our examples we are going to start from 5 and we're going to end up in 30, and we'll take this many steps. So let's see what is going to be the result and run. So this is going to start from 5, and then we want to have 33 steps. So this means that we're going to see 33 numbers here, which are evenly distributed. So this is going to be, in fact, 5.781 minus 5. This is 0.781 spacing between each step. This can be proved, for example, plus 16.719 is 70.05. Here's the next step, and so on and so forth. So yeah, we're going to be using this a lot when we're exploring the topic of matplotlib, which is going to be in the next tutorial. Thank you for staying until the end. If you have any questions, please get in touch with me. My email is camelia.gelasco@gmail.com. You can contact me at any point and ask questions, especially on Tuesdays when we have dedicated tutorials. But yeah, just drop me a message and I'll get back to you as soon as I can. Well, thank you so much, guys, again, and see you next time.